In this section, we're going to look at solving proportions by parts. If you look at their example on page 156, it says for every 5 votes Leo received from his teammates, Bob got 3 votes. If each one of the 32 players voted once, how many votes did each boy receive? So you can see from the information here there was a 5-to-3 ratio, like the book mentions, that Leo got 5 votes for every 3 votes that Bob got. There's a few different ways that we can go about solving this. We'll look at here in a minute. One way of doing this is to make a model. We know that there were 32 people, and we know that Leo got 5 votes for every 3 votes that Bob got. So what we can do, like the book mentions over to the side here, is we can just add counters to both sets in this 5-to-3 ratio until we get a total of 32 counters. So if we do 5 and 3, we know that that's 8. Another 5 and 3 would give us another 8, so that'd be a total of 16. Another 5 and 3 would give us 8 more, which is 24. And then another 8 more would give us 32. So this would be a way of modeling this. And then if you look at this, this would tell us that Leo got 20 votes and Bob got 12 votes. And that was a total of 32 votes. Another way of doing this is we can make a table, and we can start with the ratio of 5-to-3 and then multiply both of those by the same number until we get where the two numbers add up to 32. So you can see they started with 5-to-3. They multiplied both of those by 2, and that gave them 10-to-6. 10 plus 6 equals 16. They went back to the 5-to-3, multiplied them both by 3. That gave them 15-to-9. 15 plus 9 is 24. And finally, they multiplied both of them by 4. Gave them 20 and 12. 20 plus 12 is 32. So also here, same answer, just a different way of getting it. And one way you could have done this also, if you're even doing it this way, you could just say, with the 5-to-3 ratio, we have a total of 8, and you could think about, we want to get 32. So how do we get from 8 to 32? Would be multiplying by 4. And so then we know we could just take those original numbers that we had and multiply both of them by 4 to get the new numbers that we need that add up to 32. Another way that we could do this is to make a proportion. So if we look at this, Leo got 5 votes, Bob got 3 votes. So basically then we could say Leo got 5/8 of the votes. So we're trying to figure out how many votes he got out of 32. You can do the cross multiplying like the book's doing. Otherwise, this is an easy pattern here. 8 times 4 is 32. So 5 times 4 is 20. And then once you got that, you could check your answer either by cross multiplying like the book did, or just reducing your fraction. If you reduce 20 over 32, that'll reduce down to 5/8. Or you could just divide it out. If you have a calculator, you're allowed to use 20 divided by 32, and you should get 0.625. 5 divided by 8, you'll get 0.625. And then we could do the same thing for Bob. So Bob got 3/8 of the votes, and same idea. You can do what the book did, or otherwise you can take the pattern, multiplying by 4. Make sure you're going towards the variable. So 3 times 4 is 12. look at example 1. Pat mixes 5 quarts yellow, 2 quarts orange, and 1 quart white paint. If she wants to make 16 quarts of this mixture, how many quarts of each color does she need? So if you look at this, we can figure out altogether with that ratio 5, 2, and 1 how many quarts that would involve. And if we take and find that total, basically doing 5 plus 2 plus 1, which would be 8. So that ratio involves 8 quarts. We want to make 16 quarts. So basically we're just doing a double recipe here. So if you just double each one of those, that would give you 10 yellow, 4 orange, and 2 white. Okay, so nothing wrong with what the book is doing here, but if you wanted to just say, we have 8 quarts total, and we're trying to get to 16 quarts. So we know we just multiply it by 2. So take each of your different colors, multiply them by 2, and that'll give you the answers that you need. Look at the try these. Number 1, Jack and Lee shared the driving during a trip across the country. For every 150 miles that Lee drove, Jack drove 200 miles. The total driving distance was 2,800 miles. How far did each person drive? Okay, so we got 150 and 200. Gives us 350 total. So one way of doing this, we could do a proportion. We could say Lee was 150 out of the 350 miles, and we're trying to find how many out of 2,800 miles. Maybe we could do L for Lee. On this problem, you won't always be able to do this, but on this problem, if you wanted to, you could reduce the 150 over 350. You could easily reduce by 10, would be 15 over 35, and then you can even go further from there. We could check this out, though, and see if we do have an okay pattern as it is. If we've got an okay pattern, then it's not really going to make a difference for reducing the fraction. So if you do 2,800 divided by 350, you get 8. So that's a pretty nice number. You can see the numbers are getting bigger going towards the variable, so multiplying by 8. So if you do 150 times 8 is 1,200. So 1,200 miles that Lee drove. Presumably if we did that correctly, then we could just take 2,800 minus 1,200, and that would give us the answer for Jack. Just to be safe, I'm going to just rework this out. So Jack was 200 out of 350. We can do J for Jack. The pattern here is staying the same because we have the same numbers in the denominator. So it would be multiplying by 8. And indeed, we do get 1,600 miles. And that's kind of our way of checking it. Would be just to make sure that these numbers add up to 2,800 miles. And they do, so that's a good sign that we probably have the right answer. Another thing you could do at that point is you could just divide these out. So if you take 1,200 divided by 2,800, you get like 0.4285 something. So if we do the same thing, if we do 1,600 divided by 2,800, we get 0.5714, something like that. I wasn't thinking right at this originally, but those two decimals together should add up to 1. So depending how far out you go with the decimals, you might get 0.9999 something. If you go out far enough, basically they would add up to 1, but the decimals do keep going. So this gives you an idea of how to work out problems involving proportions by parts. Have a good day.